Okay, so this video we are going to discuss on how to apply the knowledge that you learned in the last video, like how to draw the graph and then how to apply the concept of transformation of graph, okay, in maybe some certain partial question, right? Okay, so we can have a look for example 1, our notes. Okay, so first part, they want you to sketch a graph of the curve for y equals to 3 sine x. And then please take note that they want you to sketch it from negative pi to pi. Okay, so as what I mentioned before, the question itself will actually tell you what is the domain that they want you to sketch a graph. Okay, all right. So first you need to sketch a graph first. Okay, so I hope that earlier you tried before, like maybe at home. For this example, if let's say you haven't, then maybe you can try it now. Then you can pause the video first, try it, then check the answer. Okay, so I'm going to sketch the graph now. Okay, because they want to have negative pi to positive pi, the domain, right? So I will just draw the y-axis in the center. Okay, then I'm having, let's say this is pi over 2, this is pi, then negative pi over 2, and this is negative pi. Okay, and after that, I need to have 3 units for y-axis. So I have to plan a bit before you want to sketch. Okay, right. So now, because they want us to sketch the graph from negative pi to positive pi, okay, for sine graph, right? So sine x originally is 0, the maximum value is 1, and then this one is 0 again. And then multiply 3, then my graph my y value will be at 3. Then after that, same thing happens for the x-axis here. Okay, so if you draw your graph correctly, then your graph will look something like this. Okay, so of course I can't draw it really nice. So if you in the exam, please draw it nicely. All right, so my graph will look something like this. Okay, so this is my graph for y equals to 3 sine x. Okay, all right, so after that, they tell you that the straight line y equals to kx pass through the maximum point of the curve for negative pi to pi. Okay, then they want you to find the value of k in terms of pi. Okay, so where is your line? Where is the point coordinate for the maximum point? This is the maximum point, right? Okay, so where's the coordinate for maximum point? Pi over 2 and also 3. And they said this line itself passed through this point. So that means if I want to know the value of k, I have to substitute this point into the equation here. Okay, so this is how we do it. Y equals to kx. Y is equals to 3, right? And then k you don't know. X you know that is pi over 2. Therefore, to get the value of k, it should be 6 over pi. Okay, so this is some basic knowledge about the line and also the points. So when your point pass through the line or whatsoever, you have to substitute the point into the line to get both sides equal. Okay, so this is how we do it. And after that, for third part, they want you to state the coordinates of the other point apart from the origin where the line and the curve intersect. So now they want you to sketch the line and the curve intersect. If you want, you can try to sketch the line to help you. So how to sketch y equals to kx? So for y equals to kx, it will pass through 0, 0. It will pass through the maximum point, like the question mentioned just now. Then you can use a ruler, okay, to try to connect these 2 points together and make it become a line. So you can have a look and see that the line will pass through where again. So if your graph is accurate, right, you will see that your line will pass through the minimum point of the curve. Right, so they want you to state the coordinates of the other point apart from the origin. So again, coordinates besides the origin. Therefore, there are 2 coordinates here, which is pi over 2 and 3. No need to show any steps. And then another one is negative pi over 2 and also negative 3. So these are the 2 points of the intersection between the line and also the curve. Okay, so some students will ask, hey, do I still need to put in the value for pi over 2 and 3? Yes, actually you need, because here they say a part of the origin, so origin is 0 only. Then other points that intersect, you need to list out the coordinate. So the maximum point, you also need to list out the coordinate here. All right, so this is how they might test you, okay, by related to the graph. Okay, so this is what you have for example 1. Okay, so if no problem, then we can continue to example 2. Okay, so for example 2, they want you to sketch again 2 graphs, y equals to 2 sine x. Another one is y equals to cos 2x for the interval 0 until pi. Okay, and then after that, they want you to state the number of solutions. Okay, so before that, we just try to sketch a graph that they want first. So you need to sketch 2 graphs here. The first one is y equals to 2 sine x. Another one is y equals to cos 2x. Okay, so usually for me, when I'm having the compression in the x direction, like cos 2x, cos 3x, cos half x or whatsoever, I will try to draw this kind of graph first. Okay, the compression in the x-axis one, because you need to change the value of the x coordinate, the x-intercept. So I will usually draw this kind of graph, then only I draw the basic one. Okay, so let us start. Okay, so they want you to sketch cos 2x. Okay, so again, no matter how, I will try to label it first. Okay, from 0 until pi, right? Okay, so let's say maybe this is still 1, this is 2. So again, every time before you draw, you have to pre-plan a bit for your ratio that you are using. Okay, so I assume that this is pi over 2. This is pi. Okay, this is 3 pi over 2. And this is 2 pi. Okay, so this is the original ratio that I'm using. Okay, so I'm trying to sketch cos 2x first. So before I sketch the cos 2x, I will sketch the original graph for cos x first. So the original cos x graph should look something like this. Okay, so this is the original cos x graph, cos x. If I want to draw cos 2x, what I need to do now is I need to change all the x value here and divide it by 2. So pi over 2 divided it by 2, I will have pi over 4. Okay, so originally this is pi. I need to divide it by 2. Therefore, I have pi over 2. Then for this one, 3 pi over 2, if I divide it by 2, I will have 3 pi over 4. Okay, and then for the 2 pi here, when I divide it by 2, I will have pi. Okay, so the graph that I have now for this one is already 1 equals to cos 2x. Okay, so that means this is done, and then it fulfills the interval that they want, which is from 0 until pi. Because if you look at the label now, it is from 0 until pi only. Okay, then now I want to sketch the graph for y equals to 2 sine x. Okay, so to sketch the graph y equals to 2 sine x, at 0 and 0, x is sine x is 0. At x equals to 0, sine x is 0. At x equals to pi over 2, sine pi over 2 is 1. And then after that, you multiply the 2 outside, right? So your graph becomes something like this. The y value will be a 2. And then at x equals to pi, sine pi equals to 0. So this is your sine graph. So if let's say you look at the sine graph here, you have only half cycle. Okay, because they only want you to cover the value from 0 until pi. Okay, let's not draw a nice graph with that. Okay, so my graph should look something like this. Okay, then this is y equals to 2 sine x. Alright, so you need to plan a little bit before you start drawing everything here. Alright, so for my suggestion is usually when you want to draw maybe 2 or 3 graphs together you should try to draw the graph that will affect the label of the x-axis first. Okay, then only you continue with the rest. Okay, then after that, they are asking for the number of solution for the equation. So now when they ask you to get the number of solution for equation, like this equation, right? If you look at this equation, there are two graphs actually, y equals to 2 sine x, and another graph is y equals to cos 2x. Okay, so when you have this kind of equation, right, to get the solution, you can actually try to sketch the graph separately. Okay, so like what you see here, you already sketched the graph separately in part number 1, and you look for the number of intersection point. So the number of solution here will be the number of intersection. Okay, so what's the number? How many the number of intersection points that you have? Okay, so the number of intersection point in this graph, there are 2. Okay, so you can straight away write out from the for the answer, the number of solution is equals to 2. That's it. Okay, so this is how we do it. Okay, can All right, so I hope that you roughly have an idea how we do all this kind of question. Okay, all right. Then after that, when we go to part number example 3. Okay, scroll down for example 3. For example 3, okay, actually it involves some concept that we still haven't covered it yet, but you learned it before. All right, but maybe you just discuss it first. Okay, then maybe if you don't understand, then you just keep it here, and then after that, when we go and cover the concept related, then you come back again, okay, to have a look for the solution. All right, so there's a function f. So they give a function f here, fx is equals to this, and then it is from 0 until 360, where a and b are positive constant. So the maximum value of fx is 10. The minimum value is negative 2. Okay, so maximum is 10, minimum is negative 2. All right, so first they want you to find the values of a and also b. Okay, all right, so before you want to look for the value of a and b, you look at this function first. Okay, so your basic function is cos x actually. Okay, so your basic function is cos x. Okay, so what can you do now is maybe you can do it like this. Okay, so now because they say maximum and minimum value, so maximum and minimum value actually makes the range of your graph. Okay, so I try to solve it by using the idea of range first. Okay, so you see my basic equation is cos x. So cos x is between -1 until 1. Agree or not? Okay, then you see after the cos x, you multiply it with b. So it will become b cos x. Okay, so when you multiply with b cos x, so you have to multiply b for the whole inequality. Therefore, you're having negative b and also the b. Okay, understand? All right. Then the next step is you need to multiply the negative. Okay, so when you multiply the negative, this value also need to multiply with negative. This value also need to multiply with negative. But do you still remember when we try to multiply the negative number inside the inequality, you have to change the sign. Okay, so when you change the sign, it will become like this. And then if you look at this equation, when you rewrite it again, it will look something like this. because I still prefer to put the smaller number in front, right? So negative b smaller equals to negative b cos a, smaller equals to b. Okay, then the next step is what? The next step is a. You have to plus a to your function here. So you plus a, that means again, the whole equation, you need to plus a. So here you have a minus b. This one you have a plus b. Okay, all right. So this is how we do it. Okay, and now, when you do until this step, what is a minus b cos x? So actually the a minus b cos x is your fx, clear or not? Okay, so they say your fx is between negative, between a minus b and also a plus b. Okay, so that means if you read the question again, since they say that the maximum value is 10, so that means this value itself is the maximum value, which is 10. Okay, because the range for fx is negative, is a minus b until a plus b. Therefore, the maximum value means this will be the maximum value, and the minimum value is negative 2. So which means also this value is negative 2. So from here, you can actually create two equations here. First equation is a plus b equals to 10. The second equation is a minus b equals to negative 2. Alright, so for this part, if you solve simultaneous equation, you will get a equals to 4 and also b equals to 6. Okay, so the method that I'm showing you here is a very useful method, okay, to use when they want you to find out the domain or the range, especially the range that involve the cos x and also sin x. Tangent x is not useful here, all right, but only for cos x and sin x. Usually what you can do is that you start from the range originally, which is negative 1 until 1. Okay, and then after that, you slowly to change it become the function fx given in the question. Then that will be the range for the fx already. So to me, I think this is quite useful, especially for cos and also sin. But for other value, it might not be useful. Okay, so this is what we have. All right, okay, so you solve simultaneous equation, try to get the value for 4 and 6. Okay, all right, so once you get the answer already, okay, so this part I need to squeeze it a bit on top. Okay, so since you know that a plus b is equals to 10, this is the first equation, and a minus b is equals to negative 2, this is the second equation. Then when you try to solve it, you should get a equals to 4 and b equals to 6. Okay, then now let's continue to part number 2. Okay, so for part number 2, they want you to solve the equation, but actually we haven't learned how to solve it yet. Okay, but no matter how, we just try to write out the solution. So when you want to solve fx equals to 0, that means you're having 4 minus 6 cos x equals to 0. Okay, so what's the value for cos x here? Cos x is equals to 4 over 6. And then cos is equals to, x is equals to cos inverse 4 over 6. And then I will call this, if you press calculator for cos inverse 4 over 6, right? I will call this as a basic angle. So your basic angle is 48.2. So you have to go through the 4 quadrants, okay, and see which quadrant you will have cos positive. We will learn all this in detail later, okay, in the next part. All right, but here I just go through it roughly first. Okay, so you are looking for cos positive. So in which quadrant cos is positive? This quadrant and also this quadrant. So for the first quadrant, I straight away write out the answer for basic angle. Then for the quadrant, if you want to get the answer for the fourth quadrant, you look at the graph that you draw last time, it is 360 minus basic angle. So you take 360 minus the basic angle, you have 311.8 here. Alright, so this is how we solve it. And again, the details and everything, we will cover it more. We'll cover more details, alright, in the next part. Okay, so for here, I just roughly go through with you to let you roughly know how we actually solve it. Okay, so this is part number 2. And for part number 3, they want you to sketch the graph for y equals to fx. Okay, so to sketch a graph for y equals to fx, then generally again, you have to roughly have the idea. Okay, because your function fx is equals to what? Is equals to y equals to 4 minus 6 cos x. Okay, so again, usually I will tell students, if can, you try to start from the beginning. So the cos x means what? Oh, yeah. Before I forget, then you look at the domain again. It is from 0 until 360. Okay, so for cos x, from 0 until 360, the original graph will look something like this. So this is 1, this is negative 1. Okay, so when you multiply it with 6, the graph still look the same, just that the maximum value becomes 6 and also negative 6 for the minimum value. Okay, then after that, you multiply negative. Okay, so when you multiply negative, the graph will become upside down already, but both are still 6 and negative 6. So when you reflect it, it will become something like this. Okay, then after that, you plus 4. So plus 4 means that you are moving the whole graph 4 units up. Okay, so when you want to move the graph whole units up, so you imagine the negative 6 here, right? Plus 4 becomes negative 2. 0 is a center, right? 0 is a center, so plus 4 becomes 4. So there's a line here, 4. Okay, and then 6 plus 4, you get a 10. So your final graph should look something like this. Okay, so this is a guideline for you to roughly plan what kind of ratio you want to use. So you know that from here, the smallest value is negative 2, the highest value is 10, the middle line is 4. Okay, so now you can start to form all the ratio that you want. Okay, so I can form the ratio that I want. Okay, so again, I will need to sketch a graph, plan the ratio first. Let's say this is my y-axis. Okay, so this is what I have. Okay, 4 boxes means 90 degrees, then 180, 270, then 360. Okay, so maybe I will make 2 units here. Okay, so the 4 here is like x-axis before. Okay, 4, then 6, 8, 10. Okay, then I have negative 2. Alright, so the 4 here, I label it because of, I draw a horizontal line here is because of it is a reference for your x-axis. Okay, so that means for first point, start from negative 2, because if you look at the sketch, your sketch just now, the smallest value is at negative 2. At 90 degrees, it will be at 4. Originally, it should be at the x-axis, but because you bring it up for 4 units, therefore the x-axis before now looks like 4. Okay, and then for 180 is the maximum point, which is 10. Then for this one is 4 again, and then for this one is negative 2. So if you want to draw the graph, your graph should look something like this. Okay, then go up, come down again, and then, okay, so this is what you have. Your graph is y equals to 4 minus 6 cos x. Okay, all right, so this is how we draw it. I don't know whether you have the idea how to do it or not, but hopefully from here you catch some concept and idea here. All right, okay, so this is the questions that I can find it out from the past year to test you on drawing graph and sketching graph part. Okay, of course there are more, so hopefully you can try out some other example later. Okay, so this is what we want to cover for this video. Then for the next video, we are going to cover the trigonometry identity, and after that you also need to learn how to solve the trigo equation.